Welcome to Euron everyone, and welcome to our very first lecture of Deep Learning Masters. Obviously after your roadmap and a welcome lecture. So I believe you must have gone through a roadmap and you must be aware about the roadmap. Now in this lecture, to the point, I'm going to talk about evolution of a deep learning, like why we are talking about deep learning basically. What kind of a problem that we can try to solve, what are the applications that we are using even now in our day-to-day life, which is basically coming from a deep learning. And we'll try to talk a lot about work and the industry with respect to a deep learning in this particular lecture. This is going to be a day 0 introductory lecture for all of you. So let me share my screen everyone, and here, so I have prepared a beautiful slide for all of you obviously, but before that let me talk about basically deep learning from a layman perspective, right? For anyone who is trying to start with the deep learning. So see, we were having a lot of algorithm which was nothing but a simple straight plain mathematics to perform some sort of a probability operation, some sort of a regression operation, and yes, we were able to solve some of the problem. But those algorithm, the machine learning algorithm that we try to say nowadays, so those algorithm can solve a simple problem if data set gets complex, right? If data set gets complex, if things gets complex, so in that case, those algorithm was not sufficient enough to solve those complex problems. For example, understanding an image. Now, image is nothing but a combination of pixels. The screen that you are able to see, right? The screen that you are able to see, the video that you are able to see is nothing but a combination of pixels. So if I have to train my machine to recognize me or recognize any of the text over here, so it is supposed to understand thousands of pixels and a relationship in between, and that too with a lot of data, then only it will be able to recognize. Now, but we as a human, right? We as a human, so we can recognize easily, right? We can recognize easily. Now, same recognition will not be done by child. So if you will follow along from childhood to adulthood, so you will be able to find out that as a child, we were trying to explore, we were trying to learn by looking at something, by hearing out something, by sensing something, by testing something. And as we have grown, so we have learned a lot, right? We as a human have learned a lot, and day by day, so we are learning a lot of things. We are able to digest a lot of information on a regular basis. Technically, we are learning as a human being, and we are even able to learn a complex things, right? So the things which looks complex for a machine, for a human, maybe it doesn't even looks complex, right? I can just see at this particular image, this particular slide, I can recognize that the image is basically a neural network image. Now this is me, I can recognize myself, and then I can recognize all the later, which is, and that too in the easiest possible way, right? So scientists, researcher have started exploring a way, a technique where if they can try to create a kind of a network or kind of a system, so where system will be able to understand something, system can try to find out some pattern in between the data, the way we as a human being try to find out, right? The way we as a human being try to find out. And this is where the concept of deep learning comes into a picture. Because we as a human, so we are very good at finding a pattern. We are very good at observing something. We are very good at even collecting a data, collecting information. So people have started looking for a way, and they said that okay, so the way human learns, maybe I can try to create an exact similar kind of a system even for a machines. And this is where the concept of neural network comes into picture. Now, what is a source for a human being? When we try to learn something, when we try to observe something, so it's our neurons, right? Our entire body is full of neuron, which is connected to our brain, and which is so neurons can take all kind of our data, all kind of our senses, whatever we see. So it can collect all the information, say to the central system, which is our brain. It is going to process it, and then this is something called as learning in case of human. So now scientists have started talking about a artificial neural network, a similar kind of a network like we as a human have. Now, this is where this entire deep learning evolution have started. Now, so in today's world, if I'll talk about AI, so it's a 65% application which has been powered by a deep learning. Now you will say, can you please name one or two application? I can name 10 over here. You must have seen a Dizzy Yatra, right? So when you go through an airport nowadays, you must have seen a Dizzy Yatra. So with the help of Dizzy Yatra, you have just registered your face once in a Dizzy Yatra application, and whenever you go through a gate, automatically it opens up. So basically, automatically system is able to recognize you. So that's a facial identification, a facial recognition system. In many offices nowadays, you must be able to see a facial recognition system, right? Example of a deep learning. And again, inside deep learning, there is a department called as computer vision, example of that. Now, nowadays, you must have seen even on a street, even on a road, that whenever you are going to violate a traffic signal, immediately it will try to take your picture, and it is going to send a challan to you, right? It is going to ask for the fine immediately on your maybe like a registered number or maybe an email ID. Yeah. So again, application of deep learning. So where it is able to recognize your vehicle, it is able to recognize what kind of violation you are trying to do. It is able to extract a number out of your number plate with the help of OCR or ANPR, automatic number plate recognition, and then automatically it is sending a challan to you. So again, one of the amazing application in a day-to-day life, part of computer vision once again, right? Now, Google Translator, we all have used it, right? Example of deep learning. ChatGPT, we all are using it. Example of again deep learning. The generative AI itself is a complete generative AI itself is a part of deep learning, right? So there are tons of application around you, especially in 2025, you will be able to find out which is getting derived from the deep learning. And like I have mentioned over here, 65% of today's AI application has been powered by deep learning. Maybe it's a computer vision, maybe it's a NLP, maybe it's a reinforcement, maybe it's a generative AI application that you are going to build. But yeah, it's coming from a deep learning basically. So just imagine how powerful deep learning is. And again, like I said in the beginning, that so researcher was trying to build something so which can try to mimic a human brain, and that was the evolution of a deep learning. So the way our neurons are connected, the way human being is having a neural network in between. So in the similar manner, we try to talk about a neural network and its relevant concept in deep learning. Yeah, so there are a lot of relevant concepts that we are going to discuss as we will start unfolding the lecture on day 0. I'm not going to take all those names because it will be very difficult for most of us to digest those names. Anyhow, we have to learn. So overall, we have to understand like what is deep learning, right? Now, the market is projected to reach 93.34 billion by 2028 in terms of just a deep learning, right? So industries from healthcare to autonomous vehicle. I think we all are aware about nowadays autonomous vehicle, especially Tesla and others, right? So Tesla is one of the most famous one. I believe we all are aware about it. So it's autonomous car, which can see the lane, which can see everything around the car, and which can take a decision, which can drive itself. Amazing application in a real world. And this is going to be a reality for all the country out there on this planet, right? All the countries. So again, an amazing application of a deep learning. Now, what is deep learning? I believe I have already talked about it. Yeah. So a kind of a training system, a kind of a neural network system. So which will be able to take a data, means the way we as a human try to take the data by looking at something, by sensing something, by testing something, by hearing out something. In the similar manner, we try to provide a different kind of a data to a artificial neural network. It's having its own name as well. It's called as perceptron, right? It's called as perceptron. So to the artificial neural network, we are going to provide a data, and then eventually those artificial neural network is going to learn the pattern. How? That is something that we are going to explore, right? Because this class is all about that how we are going to train a different kind of a network, by the way. So we are going to send the data. We are going to there is something called as multiple layers that we use to connect, and then with a minimum human intervention. So we try to give a capability, we try to train a model which will be able to do some sort of a task, maybe a facial recognition, right? Maybe a pedestrian recognition, maybe a people counting, maybe a particular object in a particular image or a video, maybe a text generation, right? Maybe a language translation, maybe a voice and speech recognition. Yeah, a lot of things over there. So here, previously we were talking about a machine learning a lot, like a decade back, if you'll say, right? A decade back. So obviously we were having a lot of mathematical model, and that falls under machine learning. But here we have started talking about deep learning nowadays a lot. So just a simple comparison. So here machine learning is nothing but, again, a bunch of algorithm, a collection of algorithm, or a collection of mathematical model, or like I could say mathematical equation, which can solve certain problem like a classification, or maybe a regression problem, or maybe some sort of a unsupervised problem. It will be able to work, and it will be able to give you some sort of a good result, right? A good one. But when deep learning comes into a picture, so whenever and wherever you have a very, very complex relation between the data itself, where machine learning is going to fail, then deep learning comes into a picture, and that is going to help you out in terms of solving the problem, right? For example, maybe like language translation, it's one of the complex tasks, right? Facial recognition, it's one of the complex tasks. Object detection, it's one of the complex tasks, right? Machine learning can't do it. Means it can do it, but with the worst of worst. So we have a deep learning. We have a lot of algorithm inside it, right? That we are going to explore. Now, so if I'll talk about like a basic of deep learning, like I said, that it's been inspired by a human brain, right? Human brain and the entire human body is having a lot of neurons. All of these neurons are connected to your brain. So it sends a data, right? It sends basically a data, and then it tries to learn the pattern. This is how our entire brain is designed. This is how our entire neural network has been designed, right? So in a similar manner, we are going to create an artificial neural network. So where there will be a input layer. Input layer means a data, right? Where we are going to pass the data. Like for example, for a human being, my input layer is my eyes, my ears, my skin, my tongue, right? My nose can be an input layer for me. And then there will be a hidden layer, there will be an output layer. So hidden layer, so where it will try to learn something, like our brain, right? So it try to learn something, it try to find out some sort of a pattern. That is something called as hidden layer in case of artificial neural network. And a lot of things goes inside that hidden layer. I'm not going to talk about now, but yeah. So in the next lecture onwards, obviously I have to talk about it with a mathematics and with the derivation of it, right? Output layer, which is going to give you the final output. Yeah. So neural network in the real world. So computer vision, a lot of application and example I have shown it to you, right? Self-driven car basically, or maybe a kind of a system which can recognize your face, which you will be able to find out a lot on an airport, in offices, everywhere, right? And again, so kind of a system like a ANPR, automatic number plate recognition system. So all of these things is technically an example of a deep learning and eventually a computer vision. So wherever we deal with images and videos, we say that, okay, it's a part of computer vision. Natural language processing, biggest example is the LLMs that we are dealing with since last two and a half year, right? A lot of LLMs we have seen, ChatGPT we have seen basically a Cloud Sonnet model, Gemini, Llama we have seen, basically Mistral we have seen, a DeepSeek we have seen, Shravan AI we have seen, a lot of models we have seen, right? Which is good at generating a data, which is good at understanding the pattern, generating a mathematics, solving the problems, everything, right? So again, that is coming from the NLP. Translation, sentiment analysis is one of the application, but yeah, the biggest one is LLMs, by the way, which can do all these things. Now, healthcare. So obviously, like in terms of drug discovery, or in terms of analyzing the disease, or in terms of even going through the scans, deep learning is lethal, right? Computer vision or deep learning is lethal in terms of like it is going to be fast. It is basically like in some of the area, in some of the segment, the kind of a result it is trying to like give is amazing, right? It's phenomenal. So the another one is autonomous vehicle. I think nowadays we all know autonomous vehicle is not a fancier stuff which we see just in a Hollywood movies, but autonomous vehicle is something which is a reality, right? Otherwise, we would have like seen this autonomous kind of a vehicle in some of the movies, like movies from Tom Cruise or maybe from someone else. But now it's not that fascinating things. It's a reality. We can see that on a road as well. Yeah. So this is where this thing comes into picture. Now, so when we talk about deep learning, right? So like I said, once we'll do it, we'll know it. But as this is day 0, I think we should know a little bit about something, right? So what is the life cycle of a deep learning? So first of all, obviously, like any other AI stuff, data collection and a preparation. So for example, if I'm trying to build some sort of a computer vision model, right, which can recognize something in images. So obviously I have to collect a lot of images, a lot of variation with a different lighting condition, different angles, or I can say with the different shape and sizes, from near, from far, I have to collect those images. So data collection and then preparation, pre-processing we have to do, which is pretty much and again, for a different kind of application, this approach is going to be different. It's not going to be same, right? It's not going to be same. And then there are tons of model architecture you will be able to find out. So it depends upon the task. We try to select those model architecture, by the way. For example, we talk about LeanNet, we talk about the ResNet, LXNet, we try to talk about VG16, talk about DarkNet, EfficientNet, we talk about GoogleNet, we talk about. So all these are basically for a image classification, right? Again, we talk about YOLO, we talk about basically some sort of a model for a segmentation, for a tracking, for a detection. So a different kind of applications we used to build, and depends upon the application, depends upon the problem statement, we go and choose a model, right? We go and choose the model. So model architecture selection, and again, to know that you have to go through a lot of models, right? So these are just a computer vision model again. So if I'll come on a NLP side, there is a recurrent neural network. Inside that there is a LSTM, there is a GRU, and again there are multiple different kind of a connection that you can tune in a encoder decoder. There is a transformer architecture. So a lot of things, right? A lot of things. So it depends upon the task that we are going to solve. We try to select the model architecture, and that is something that we are going to explore in depth again inside your lectures. Now, once architecture is done, once architecture selection is done, once your data is prepared, then we try to go with the training basically. So we try to feed our data, and then once training is done, we try to do our testing, and then once testing is done, then deployment comes. Now, these 5 things falls with these 5 things always comes with all the project you are going to build out there, with all the project, right? Not just with one single project, but in this 5 things, lot of things comes in between. Lot means a lot. There will be a lot of variations, a lot of different approaches you will be able to find out in this 5 things itself. Now, moving ahead. So here, library wise, so majorly a TensorFlow. Keras is a high level API which has been built on top of TensorFlow itself, and a PyTorch. There are other libraries as well, but yeah, these libraries are pretty much famous, Keras and PyTorch, and we will be using these libraries. These are basically a Pythonic library, right? Although TensorFlow supports other language as well, but yeah, Keras, PyTorch, all these are a Pythonic library which has been especially designed and built for a deep learning, machine learning, computer vision reinforcement. So we are going to use these libraries, which is going to help me out in terms of converting my conceptual understanding or my mathematics in a reality, and eventually into a real-time application. So these libraries are very easy, and wherever it is required. So again, I'm going to come and do a discussion about it in a step-by-step manner. We will go through this entire lectures. Now, whenever we are talking about this training of the model, so obviously we need a system, we need a hardware, right? We need a hardware. With most of us, right? This hardware will not be available. Hardware means most of us is having just a laptop, maybe just an i5 laptop. So this i5 laptop is more than enough for a learning purposes. Now, wherever we have to go for a heavy training, right, wherever we need a GPU, because in our laptop, most of us will be having just a CPU. And even though if you'll be having a GPU, so maybe an integrated one, or maybe not a kind of a GPU, which is required to train this heavy weighted model. So I'm going to teach you, I'm going to even talk about that how we can try to use some of these hardware which is available over a cloud, right? That's a standard approach. That's a standard way of like doing a training. So how we can try to access something which is available over a cloud, and how we can try to make use of it. Yeah. So all of these things we will be talking about inside our lecture, everything, right? Everything. So hope guys, our understanding is clear with respect to deep learning, that what deep learning is all about, obviously mimicking the human brain, and what kind of application that we are using even now. A lot of application example I have given to you that we are using in our day-to-day life. And apart from that, so what we have to learn as an algorithm, or what basically we are going to explore the entire life cycle, like starting from a data pre-processing, data collection, data pre-processing, to a selection of the model, to a training, and then testing, and then finally a deployment. So this entire cycle we are going to close. And again, so system wise, it's completely fine. If you have just a i5, it is going to work. It is going to work and wherever it is required. So obviously I'm going to tell you that, okay, fine. So you can try to use this particular cloud platform, and this is going to help you out. So with that understanding, guys, I'm going to stop myself over here, and let's begin chapter number 1 of Deep Learning Masters from next class onwards. With that, thank you so much, everyone. Take care. See you again in my lecture.